It sounds like a mistake, but it is a scientific reality. Humanity has successfully reached Jupiter 7 times, even though it is 8 times farther away than Mercury. We have explored the outer reaches of Saturn and Neptune, yet we have only managed to visit the planet right next door twice in history. For 30 years, there was absolute silence. Is this scorched rock simply too boring for science? Or is there a deeper reason we are afraid to speak about welcome to one of the most dramatic puzzles in space exploration? This is a story where proximity is a curse rather than a blessing. To reach Mercury, one genius specialist in orbital mechanics had to devise a flight path that looked like total madness just to cheat the laws of physics. You see, space is not a straight highway where you can simply press the gas and go. It is a treacherous web of gravity, and Mercury sits right in the jaws of the ultimate monster, the Sun. Our star creates a massive gravitational funnel that forces anything heading toward it to accelerate uncontrollably. It is like sliding down an icy slope. The further you go, the harder it is to stop. As a spacecraft hurtles toward Mercury, engineers face a terrifying realization. Without an incredible plan, the probe will scream past the planet like a bullet, with no hope of slowing down to enter orbit. But speed is only half the battle. Mercury is bathed in a solar furnace, where the surface temperature can reach 800 degrees Fahrenheit. This means any probe sent there cannot just be a machine. It must be a high-tech thermos with an engine, capable of surviving in an environment where lead would turn into a puddle. The sunlight there is 7 times brighter than what we experience on Earth. 7 times. Imagine a light so intense that it could melt even the best protective shields. To break in these hellish conditions, you need fuel, massive amounts of it. But here's the classic space trap: the more fuel you carry, the heavier the spacecraft becomes, which means you need even more fuel just to lift it off the ground. It is a vicious cycle with no apparent exit. This explains why the first mission to Mercury, Mariner 10, did not happen until the mid-70s, long after we had already walked on the moon. Even then, that probe could only manage a quick flyby, capturing images of just 40% of the surface. More than half the planet remained a complete mystery for 30 years. An entire generation of scientists watched as we explored the outer solar system, while our closest neighbor remained a blank spot on the map. Ironically, it was the very proximity of Mercury that made it so unreachable. In the mid-1980s, a quiet revolution occurred in the world of astronautics. A specialist in orbital mechanics named Chen-wan Yen sat over his calculations and realized something staggering. He understood that we didn't need to fight the sun's gravity with brute force. Instead, we could outsmart it. His idea was to use the solar system itself as a giant braking mechanism. It was a concept so unconventional that, at first, many people simply could not grasp how it would work. Instead of flying toward Mercury in a straight line, the probe would take an incredible detour. This plan required the spacecraft to orbit the Sun 15 times. It would have to fly past Earth once, swing by Venus twice, and pass Mercury itself 3 separate times, just to slow down enough to finally enter orbit on the 4th attempt. In space, the shortest path is almost never a straight line. Yen proposed using the planets as natural brakes, where every flyby was an opportunity to hook into a planet's gravity and shave off speed without using a single drop of extra fuel. This journey was designed to cover nearly 8 billion kilometers. To put that in perspective, it is like flying from Earth to Pluto and back again twice. The entire process would take 6.5 years of circling the solar system, 6 years of waiting, calculating, and correcting. A single mistake or one wrong calculation would mean the mission was over. The spacecraft would either vanish into the void or be swallowed by the sun. This is the true beauty of engineering, using the elegance of mathematics to turn your greatest obstacles into your strongest allies. The great endeavor finally began in August of 2004, when Messenger roared off the launch pad and into the history books. But this was not a sprint to the finish line. It was the start of a marathon that would test the limits of human patience and engineering. The first year of this journey was spent in a wide, sweeping arc around the sun, eventually bringing the spacecraft back toward its home. This return to Earth was not a mistake, but a brilliant, calculated move. Scientists used our own planet as a laboratory in the sky, a final testbed to ensure every sensor and camera was perfectly calibrated, because we understand Earth's atmosphere and magnetic field so deeply. Any tiny error in Messenger's instruments would have stood out immediately. Fortunately, the systems performed with flawless precision. After capturing hauntingly beautiful images of the Earth and Moon, the probe adjusted its course and plunged deeper into the heart of the solar system. It was during this phase that the mission began to display true engineering magic. As Messenger moved closer to the Sun, the team decided to use the pressure of solar radiation as a cosmic sail. It sounds like science fiction, but it is a physical reality when sunlight hits the solar panels. It provides a tiny, physical push, while this force is nearly invisible to the human eye. Over the course of 6 years, these microscopic nudges added up to a significant change in speed. By sailing on the light of the sun, the team was able to save precious fuel that would be desperately needed later in the mission. Every single gram of propellant was treated like gold, as there was no way to refuel once the journey had begun. 2 years into the flight, the spacecraft reached its first major milestone, a flyby of Venus. However, the geometry of the solar system can be a cruel mistress. During this first encounter, Venus was positioned directly on the opposite side of the Sun from the Earth. This created a total radio blackout, leaving the team on the ground in a state of agonizing silence. Messenger was entirely on its own, flying past the hellish clouds of Venus without any contact from its creators. While it did manage to snap a few photos, it was unable to perform any complex scientific experiments during that pass. This serves as a stark reminder that in space, we do not dictate the rules. We simply learn to survive them. The second encounter with Venus, however, was a triumph of international cooperation. By the time Messenger returned to the planet, a European probe called Venus Express was already in orbit. For the first time in history, 2 different spacecraft from 2 different nations conducted simultaneous measurements of the Venusian atmosphere and the solar wind. It was a beautiful moment of human unity, proving that the pursuit of knowledge has no borders and no politics. Together, they painted a more complete picture of our sister planet than either could have achieved alone. With the help of Venus, Messenger was finally ready to face its ultimate destination. After 4 long years of chasing shadows and dancing with the gravity of multiple planets, the moment of truth finally arrived. In early 2008, it was the dead of winter on Earth when Messenger made its first high-speed pass over the surface of Mercury. The spacecraft's cameras clicked incessantly, capturing every crater and ridge, while scientific instruments worked at maximum capacity to drink in every bit of data possible. This first encounter was a resounding success, followed shortly by a second flyby that went just as smoothly. Back on Earth, the team of scientists and engineers began to let their guard down, believing that the most treacherous part of the journey was finally behind them. But space has a way of punishing overconfidence when you least expect it. In 2009, during the third and final flyby before entering permanent orbit, the mission nearly met a catastrophic end without warning. Messenger suddenly slipped into an emergency mode. Its automated protection systems triggered, shutting down all scientific instruments and leaving only the most vital survival functions running. One can only imagine the suffocating tension in the mission control room as the signal changed. This small, lonely probe had already traveled 8 billion kilometers and survived years of solar radiation, only to face a potential total loss just as it reached its goal. The crisis began when the probe entered the shadow of Mercury, a period of 18 minutes of total, absolute darkness. In this shadow, the solar panels were useless, and the spacecraft had to rely entirely on its internal batteries to stay alive. Deep within the power management software, a tiny, hidden glitch lay in wait. It was a small error in the code, but in the unforgiving environment of the inner solar system, there is no such thing as a small mistake. The system panicked, and for 7 agonizing hours, Messenger remained in emergency mode on Earth. Those 7 hours felt like an eternity. Engineers sat in silence, staring at empty monitors and praying for a signal to return. Some rechecked calculations for the 1000th time, while others could do nothing but wait for the probe to find the light.
It was a chilling reminder
Finally,
that a mission worth
as the
hundreds
solar
of
panels
millions of
caught the
dollars
sun's
can turn
rays
into
once
space
again,
junk
the
because of a
computer
single
successfully
overlooked
rebooted
variable.
itself. The signal flickered back to life, and the mission was saved by the narrowest of margins. It was a chilling reminder that a mission worth hundreds of millions of dollars can turn into a piece of space junk because of a single overlooked variable. Fortunately, luck and brilliant engineering were on their side, and the path to the final orbit remained open. In March of 2011, humanity achieved what was once considered impossible. After a journey spanning nearly 7 years and covering 8 billion kilometers, the Messenger probe finally entered orbit around Mercury. It was a triumph of human ingenuity and a moment that changed our understanding of the solar system forever. For the first time in history, an artificial satellite began to circle this elusive world, but it did so in a very peculiar way. The orbit was not a perfect circle. Instead, it was a highly stretched, elliptical path. At its closest point, Messenger would skim just 200 kilometers above the scorched surface, only to swing out to a distance of 15,000 kilometers. This was not a mistake in navigation, but a vital survival tactic. You see, Mercury acts like a giant mirror, reflecting the intense heat of the sun back into space. If the probe stayed too close for too long, even its high-tech ceramic shield would fail to protect it from the furnace below. Every 12 hours, the spacecraft had to retreat into the cold of deep space to allow its systems to cool down. It was a rhythmic, cosmic dance approach to the planet. Capture the data, and then flee to the shadows to survive. The original plan for this mission was modest, calling for only 1 year of scientific research, but Messenger proved to be a true hero of space exploration. It defied the odds and continued to function for 4 incredible years in one of the most hostile environments imaginable. During this time, the temperature outside the probe swung wildly from unbearable heat to the absolute cold of the cosmic void. Yet every system held firm. Before the launch, scientists had hoped to receive at least 1,000 photographs of the surface. In the end, Messenger sent back more than 200,000 high-resolution color images, covering every single square inch of the planet. What this little probe discovered during those 4 years was enough to fill a library of scientific journals. It mapped the surface in such detail that we could finally see the scars of Mercury's ancient past. But the most shocking discovery came from the planet's poles, in a place where the sun never shines, deep inside the shadows of permanent craters. Messenger found ice. It seems like a paradox finding frozen water on the most scorched planet in our neighborhood. Yet there it was, hidden in the darkness, beyond the ice. Messenger peeled back the layers of Mercury's mysterious magnetic field. We learned that the field is far more complex than anyone had predicted, suggesting that the internal structure of the planet is still active in ways we are only beginning to understand. The probe also found evidence of ancient volcanic activity, proving that Mercury was once a world of fire and flowing lava. The surface we see today is a record of catastrophic events that occurred billions of years ago, preserved in the silence of space. Every answer provided by Messenger seemed to spark 10 new questions, peeling away the veil from a world that had been a blank spot on our maps for far too long. Nothing in our universe lasts forever, not even the most heroic of explorers. By the end of 2014, the fuel that had been so carefully guarded and rationed over 10 long years was finally running dry. Without the ability to correct its course, the gravity of the sun and the planet began to pull the spacecraft closer and closer to the surface. During those final weeks, Messenger provided us with one last thrill, skimming just 25 kilometers above the ground, a height lower than many commercial airplanes fly above the Earth. On April 30, 2015, after a journey of 11 years and 8 billion kilometers, the mission reached its inevitable conclusion. With one final silent impact, Messenger struck the surface of Mercury, creating a new crater on the ancient, battered landscape it had spent years documenting. There is something deeply symbolic about this ending. Messenger did not simply disappear, it became a permanent part of the world it studied. Its remains now rest forever in the intense solar heat, a lasting testament to human curiosity and the genius of engineering. This mission was much more than a collection of data and photographs. It was a masterclass in turning obstacles into opportunities and proving that patience and precise calculation will always triumph over brute force. Sometimes, as this mission showed us, the longest and most difficult path is the only one that leads to success. The legacy of this project lives on through the work of Chen-wan Yen, whose mad idea to orbit the sun 15 times proved that we must think differently when faced with impossible challenges. He didn't ask how we could carry more fuel. He asked how we could do more with what we already had. This shift in perspective is what allowed us to unlock a door that had been locked for 30 years. It reminds us that when we hit a wall in life, we shouldn't always try to break it down with force sometimes. The most elegant solution is to find a way to use the wall itself to our advantage. Today, the exploration of Mercury continues with the Bepi Colombo mission, a joint effort between Europe and Japan. This new mission is even more ambitious, carrying 2 separate probes that will study the surface and the magnetic field simultaneously. Even after all the discoveries made by Messenger, Mercury still guards many of its secrets. We still wonder why such a small planet has such a powerful magnetic field, or exactly how ice can exist in a place where the surface can melt lead. The story of the Messenger is a reminder that science never truly finishes its work. Every answer we find only creates 10 more mysteries to solve. It teaches us the value of the long game, the 10 years of waiting, and the 6 years of flying that were required to achieve just a few years of discovery. In a world that demands instant results, space exploration teaches us the beauty of patience. Messenger proved that the most difficult questions are the ones most worth asking, because it is on the edge of the impossible where we truly find out who we are. This small probe with a big mission left behind a full map of a world that was once a blank space. It provided the inspiration for a new generation of scientists to keep looking toward the stars. As Bepi Colombo follows its own winding path through the solar system, it walks through the door that Messenger opened. The mission is over, but the light it shed on the dark corners of our solar system will never fade.